This screencast is about properties of liquids, specifically unique properties of water due to the hydrogen bonding, and this is directed at AP Chemistry. All right, so we know that water has hydrogen bonding, and we know that hydrogen bonding is when water arranges itself so that the positively charged hydrogen is near an adjacent oxygen on a different molecule, and that causes them to create a hydrogen bond between that hydrogen and oxygen, which is not a bond, but it's an intermolecular force. And a hydrogen bond is one of the strongest intermolecular forces. So one of the properties that is specific to water and other liquids is viscosity, and viscosity is how fast a liquid can flow. Some liquids will flow very slowly, like molasses or motor oil, and some liquids will flow very quickly, like water. And the graphic that you see here on the left is 5 different substances with a very quick flowing liquid, and that would be a low viscosity, up through a very slow flowing liquid, which would be a high viscosity. Okay, if you can zoom in and look at this other image here on the right, it says this is water, milk, oil, light syrup, heavy syrup, and chocolate syrup, and you can see that the image shows that they flow much slower as you progress, and so the viscosity is much higher on the side. So we would say that the chocolate syrup has a very high viscosity, and that's because the substances do not move past each other very well at all. Another property of liquids is surface tension, and surface tension is all the IMFs, all the molecules on the surface are lined up in a way to create a skin, and so they are all attracting each other on the top, and there's no need to attract anything from above, so they're not worried about anything up here because the liquid is not there anymore. So we have all these liquid molecules that are below, and they only need to focus on the sides and below, so that causes it to have a very a higher surface tension, or an ability to hold things off or together that you would not expect. So the image here is a paper clip floating on the top of a cup of water. Pond skimmers take advantage of surface tension. Water has a really good surface tension because, again, water has hydrogen bonding and a very strong IMF. And since they are all directed towards the sides or the bottom, the molecules have arranged themselves in order to create a very strong attraction on the top. All right, cohesion and adhesion are usually linked together. Cohesive forces are when water sticks to other water, or any other substance sticks to itself. And adhesion is the substance sticking to something else. So in our graphic over here, you can see cohesion, water and water sticking, and adhesion, water and a leaf sticking. So in the image here with the droplets, you have both cohesion and adhesion. The cohesion causes the water droplets to get large because they're sticking to each other, and the adhesion is that they have stuck to whatever this surface is. It looks like maybe a skillet or something, I'm not quite sure. But the water droplets would be able to cling to the surface. You see this often when dew forms on grass blades. Again, the stickiness or the attractive forces are due to, for instance, in water, the hydrogen bonds, or in other atoms and molecules, it would be the other IMFs. So some liquids would have more of a attractiveness to itself and other things, and some would have less. The last property that we're going to look at is capillary action, and you would have experienced capillary action a lot more in biology. Plants use capillary action in order to manage to pull liquids up into the stem of the plant. And so capillary action is when you put a narrow tube into a liquid, it'll draw itself up higher inside the straw than outside. And it's due in part to cohesion and adhesion, but it's also due in part to the pressure. So you have the liquids inside this straw is much higher because it's a narrower capillary than in this straw because it's wider. So you can see that the liquid is more likely to travel higher in a thinner tube or a thinner capillary than it is in a larger tube. So those are some properties of liquids, and they suit water uses those to their advantage a lot, and that's how life is able to flourish, because water has really strong intermolecular forces and it is able to have the properties that it does have.